for the first of our additional Q problems. We're given this one. Here's the expression. And we're given these as the pressures. So we have to write the equilibrium expression for pressure for this reaction. Now, this is something that was challenging for many people on the test. Once it says for pressure, we need to write it in this form. All right, it's Kp, and it's not the brackets, it's the partial pressure of HF squared times the partial pressure of H2 and the partial pressure of F2. So there's the first point. Left one off. And we also need to calculate the reaction quotient. So that means I just need to take these and insert them into this. So my second point is just by plugging them in and doing some math, the reaction quotient is 1.778. All right, then what direction? Okay, it's important to answer these in this fashion. What direction will it shift, and then explain. So the first thing I say is the direction it will shift. The reaction will shift to the right. All right, now also product side. Anything that indicates that you understand that it's going to shift in that direction will work. But then explain. So from here on, this is my dividing point. This is the first part. Now this is the explain part. This makes sure that the grader can recognize and give you your points. So you can see I mentioned the QK relationship. That's important, right? And then I indicate how we have to change the products versus reactants. Makes it totally clear that you understand what is happening here. Then we get to the longer one, calculating the equilibrium pressure for each gas. The first part of this and the first point is something equivalent to doing an ice table. So when we get an ice table put together, we are showing that we understand the relationship, and that's the change line, that for every x of the H2 that disappears and every x of the F2 that disappears, that ratio is 1 to 2. So we're going to gain 2 of the hydrogen fluoride. So we get our equilibrium concentrations. At this point, it's now just a big algebra problem, because once you've established this and gotten your first point, you go into the process of plugging it in. We were given the K, and we plug our numbers into the expression. We notice, oh look, it's a perfect square situation. So we take the square of each side. When we evaluate that, we have eliminated our squared terms, so we are not going to have any quadratics. We're just going to have to solve for x. So at this point, it's a question, can you distribute by moving the denominator over to the left side of the equal sign? And then can you determine the value of x? Once you know the value of x, you have to plug it in. All right, so these two partial pressures are the same, and they were both 0.6 minus x, and now that I substitute x in, I get their equilibrium pressure. And then for hydrogen fluoride, I substitute 2 times x into its expression, and I get its partial pressure. So this is where you get your point. All of the work before that is not worth the point. It's the fact that you can do this math without making a mistake. This might seem a little unfair that you've got all this work and you only get the point for getting the right answer, but essentially what we're saying is that in the first part, you get a point for understanding chemistry. And in the second part, you get a point for doing math. And it doesn't matter if you make a mistake up here when you're going from this step over to the next one, or if you make a mistake down here where you're just subtracting. A math mistake is a math mistake. And if you don't get it, then you don't get it.